Okay, today what we're going to do is look at conditional probability and two-way frequency tables. So the first thing we're going to look at is a few definitions. So conditional probability is given events A and B. Conditional probability is the probability of event B occurring, knowing that event A has already occurred. So our notation is the probability of B given A. And we're going to write it with that slash right down the middle. The formula that we're going to be using is going to be the probability of A and B in the numerator over the probability of A in the denominator. The second thing that we're going to be looking at today is a two-way frequency table. And that's a table that records data that pertains to two different categories. We're going to start off with some practice with conditional probability and then work our way into the two-way frequency table. So in our first example, Sarah drew a card from a standard deck of playing cards. What is the probability that she drew a queen, given that the card was red? So the first thing that we want to say is that we want to know the probability of drawing a queen, given that it was red. Exactly what it said in here, that's what I put here. So we're looking at the probability of it being red and a queen over the probability of being red. So the probability that the card is red is going to be 26 over 52. The probability that it's going to be a queen is 4 over 52. And then all over that 26 over 52. Now what we know about this is that 26 over 52 is going to cancel in the numerator and denominator, leaving us with just 4 over 52, and that simplifies to 1 over 13. Now we could just look at this problem and say, what is the probability that she drew a queen, given that the card was red, and we might know that it's 1 over 13, and that's fine as well. The second thing that we're going to look at is there are 62 people that take a yoga class and 48 people that take a spinning class. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she takes a yoga class if you know that they also take a spinning class. So once again, we're looking at that probability of A and B over the probability of A. When I saw this problem, the first thing I also wanted to do was I know that 15 people take both yoga and spinning. So I decided to make a Venn diagram chart. I know that 15 people take both yoga and spinning. So if I take 62 minus 15, that means there's 47 people who just do yoga. And if I do 48 minus 15, there's 33 people who just spin. What I need to know is, if chosen at random, find the probability that he or she takes a yoga class if you know that they also are taking a spinning class. So that means that the probability is going to be 15 over that 48 people who take the spinning class. So 15 over 48, which is going to simplify down to 5 over 16. The next thing that we're going to look at is some two-way frequency tables. At the top of this page, I just wanted to kind of go over that conditional probability so we didn't forget what we're looking at. The probability of A and B is sometimes going to be right in that chart over the probability of A. So in this first example, the table shows the results of a poll of 50 random selected students who were asked whether they prefer to watch hockey or football. Find the probability. So in this first example, we need to find the probability of they prefer football given that they're a girl. So though I looked here and I said 18 and 6 gets me 24, 10 and 16 gets me 26, 18 and 10 gets me 28, and 6 and 16 gets me 22. Kind of making those tables. What I need to know is the probability that they prefer football given that they're a girl. So, probability that they prefer football and they're a girl is 6. How many total girls are there? 22. So that probability is 6 over 22, and if we simplify that, we get 3 over 11. Same idea in problem in part B. Probability of a boy given that they are going to prefer hockey. So where's the boy and the hockey overlap is going to get me 10. And then I need to know how many total people preferred hockey. Well, that's 26. So that's going to be 10 over 26, and that reduces down to 5 over 13. So we're looking for that intersection of the boy and hockey, just like the Venn diagram, over the total number of people who prefer hockey. Let's try one more example. In example 2, the table shows the results of a poll of 150 randomly selected middle school students who were asked if they take French or Spanish. So the first thing I did is I did my totals column, and I know there's 150 total. In part A, it says, what's the probability of a 7th grader who takes French? So not really the conditional probability that we've seen with that slash down the middle. I just need to know how many 7th graders take French out of my total 150. So here, there's 25 7th graders who take French out of my total of 150. And that's going to simplify down to 1 over 6. In part B, I need to know the probability of an 8th grader given that they take Spanish. So once again, where's that intersection between an 8th grader who takes Spanish over the total number of people who take Spanish? So that's going to give me 33 over that 68. And that doesn't simplify down. In part C, what's that probability that that person takes French given that they're a 6th grader? So once again, where's that intersection that they take French and they're in 6th grade? That's 19. And then how many total 6th graders are there? Well, there's a total of 42. So my probability should be 19 over 42. And in this last example, what's the probability that they're a 7th grader given that they take French? So once again, what's that intersection of a 7th grader who takes French? Scroll back up. That's 25. How many people take French? That's 82. So my probability should be 25 over 82. So if there's any questions, please reach out. But once again, this is looking at conditional probability and two-way tables.